video lectures available on YouTube. So I think we are ready to go. So as the usual lectures follow this rule, we have questions being taken at the end. We'll give around 5 minutes for that. In the meantime, if you have any doubts, you can put that in the chat box as well. If you have any audio issue, please feel free to put that in the chat box immediately. We shall look into that.
Okay, sir.
So now I'm going to mute you all, and you can either raise hands for the questions or you can put that in.
Sir? Sir?
సార్ మీరు మ్యూట్ లోకి వెళ్ళిపోయింది సార్.
Sir? Sir, Vedic Math only on
Whether I was audible or not.
Sir, you were talking on mute, so you have to repeat.
Oh, okay. I'm sorry. So I'll just begin from the first. So what we were dealing with was divisibility by 6 and 15. So yesterday we talked about divisibility by 3, which was actually enabling us to use the digit sum idea to see if the digit sum was equal to 3, 6, or 9. So an extension of this would check for divisibility by 6. The only additional thing that you have to do is to check whether the number is even as well. So if the number is divisible by 3 and the number is even, then it is going to be divisible by 6. Let's see the next one, which is divisibility by 15. For the number to be divisible by 15, it has to be both divisible by 3 as well as 5. So how do we check divisibility by 3? The usual game follows. So whether this is going to be having a digit sum equal to 3, 6, or 9, that can be easily checked. So 4 plus 5, we have seen how we can cancel or cast out 9s from the digit sum. The remaining digit sum is going to be 6. So this is going to be divisible by 3. What about divisibility by 5? We have briefly talked about that yesterday. And we said that a number that ends in 5 or 0 is divisible by 5. So hope these concepts are understood. Let us do a few practice here. What about 432? It is an even number. We have to say which whether it is divisible by 6 or 15. Now divisibility of 3 you can find by the digit sum. Here it is equal to 9. So this is divisible by 6 and not 15. What about 555? the sum of the numbers is going to be 15. So the digit sum is 6. So it is divisible by 3. And the last ending number is going to be 5. So it is divisible by 5. So this goes well with 15. It doesn't go with 6 because it is an odd number. What about the third example? 222, digit sum is 6. And the last ending number is 0, or ending digit is 0, which means that we can have this entire number divisible by 15. What about 6? This is an even number, and it is also having a digit sum which is 6. So that test also satisfies. What about 4360? We can cast out 6 and 3 because of the 9 in the digit sum. 4 and 0 digit sum is equal to 4. And what we are left out is, in fact, not divisible by 3. So this does not divide both 3 and 15. So we'll just put a cross mark to indicate that. I'll just do one of these in the practice. 5, 6, 1. Let us see if we can cast out anything. So nothing to cast out. So the digit sum is 12. In fact, the sum of the digits is 12. The digit sum is hence 3. Now it is divisible by 15 because the ending digit is 0. So 15 goes. What about with 6? It also goes with 6 because it is an even number. You can try the remaining 2 at home. Now is the more important task on checking your solutions after you do a particular operation. So what we are going to do here is how to do digit sum checks for addition and multiplications. This is also called as sanity checks. So sanity check is something like you check for the correctness of a solution after you perform that particular operation. Now this is very important while you do long additions or long multiplications. Let us see a few examples. So we are going to add 88 and 46. What is the easiest way? We have learned how to do that from left to right. In Vedic mathematics, the usual procedure is from left to right, although conventionally you are allowed to do from right to left. So from left to right, we get 4 plus 8, which is 12, that we'll put as it is. And there is 8 plus 6 going to be there, which is 14. We'll write it a different notation. 14 is written 4 with a large alphabet or a large letter, and 1 is just subscripted to indicate it is going to add with 12. So the final answer is 134. This can be done in mind as well. Now let us do the sanity check or the digit sum check. Digit sum of 8 and 8. Sum of digits is 16, so the digit sum is going to be 7. The digit sum of 4 and 6 is going to be 1 because 4 and 6 adds to 10. What about the digit sum of 134? 4 plus 4, which is going to be 8. So you can see the digit sum also add if the answer is correct. Let us see one more example. 187 plus 4, 4, 6. What is the left to right addition? 5, then 12, and 13. So the final answer is going to be 3, 3, 6. What is the digit sum of 187? It is going to be 1 and 9, 1 and 8 you can cast out. So the digit sum is 7, 4, 4, 6. So this is having sum of digits 14. So digit sum is 5. Digit sum of this, you can cast off 3 and 6. The digit sum is 3. Now, how can you equate 7 plus 5 to give 3? This is the entire thing that we learned in the 9-point circle. 7 plus 5 is actually 12, but the digit sum of that 12 is 3. So digit sum of 3 plus 3 plus 9 is also the same. Let us go ahead. So the last example that we are going to see is a 4-digit addition. So 5 in the leftmost place. How about 5 plus 3 plus 6? This is 14. We are going to write like this. This is going to be 8. And the last place we have 12. So the addition is going to be 2, 9, 4, and 6. Let's check the digit sum. So digit sum here, the sum is 20. So digit sum is 2. The digit sum here is going to be 7. What about this? You have 6 plus 2, 8 plus 4, 12, or digit sum is 3. So the total digit sum going to be 2 plus 7 plus 3, which is again going to be 3. Let's check whether digit sum 3 is obtained from the answer. You can cast off 9. What remains is 6 plus 6. So the digit sum is 3. So we have verified the digit sum of the sum 2 plus 7 plus 3 is going to be 3. So some more practice. I'll just do one from here. Let me do this one, the fourth one here. The addition, always look from left to right. The leftmost place is 5. Then we have 4 plus 8, which is 12. 6 plus 6, which is 12. And 8 plus 5, which is 13. Let us do this addition. 3, 3, 3, and 6. What about the digit sum? Is there anything to cast out? So let us do the addition as it is. So this is 2 plus 4, 6, 6 plus 6, 12 plus 8, which is 20. So digit sum is going to be 2. Digit sum over here, is there anything to cast out? So if there is nothing to cast out, you can do one trick. You can borrow 1 from 3 and give it to 8. So what remains in 3 is 2. And then 8 plus 1 will be cast out. So 2 plus 6 plus 5, which is 13, having a digit sum of 4. Now here in the answer, you have a lot to cast out. So you can cast out 3 and 6. And finally, you will get digit sum equal to 6. So hope you have understood the sanity check rules using digit sum for addition. Let us go ahead. Now next is for multiplication. We can use the same rule. What about 78 times 3? The easiest way to do this is 80 times 3 minus 6. So 80 times 3 is 240 minus 6 is 234. So what is the digit sum of 7 and 8? It is 6. Digit sum of 3 is this. What is the digit sum of the answer? It is going to be 9. So you can see the digit sum of 6 into 3, which is 18, is going to be satisfied here. 18 is also having a digit sum of 9. What about 67 into 7? So you can do 70 times 7 first, which is 490 minus 21. So if you take 20 from 490, it's going to be 470. 469 is going to be the answer. The digit sum here is 1. Digit sum here is 4. Digit sum here is 7. So multiply 4 times 7, which is 28, having a digit sum of 1. So this is the sanity check that we did for multiplication of a 2-digit number with a 1-digit number. Now, let us do the remaining 2 as well. First, we'll find the digit sum here. Digit sum of 8 and 8 is going to be 7. Digit sum of 6 is going to be 6 itself. Multiply these two, 42. Digit sum is again going to be 6. Now let us find the answer for this. Do 90 times 6, that is the closest base to 88. So 90 times 6, that is going to be 540. 540 minus 12, which is equal to 528. So does 528 have a digit sum equal to 6? That is the check. So this adds up to 15. So the digit sum is again equal to 6. So this is satisfied by the sanity agreement. What about 63 times 8? Do 60 times 8 plus 3 times 8. So 60 times 8 is 480 plus 24 coming from 3 times 8. So that is 504. Now the digit sum here is 9, digit sum here is 8, 72 has digit sum of 9, and the answer as well has digit sum equal to 9. Some more practice. I'll urge you to do it at home. We'll just take one example from here. Let's do the first one, 66 multiplied by 6. Let me do this a little bit differently. I'll write 66 as 11 times 6, but 11 times 6, so again I can group 6 times 6, which is 36. What is the easiest way to multiply a number with 11? We have seen that in one of the previous lectures, and in this lecture also we shall do that in detail. So first put the digits of 3 and 6 separated by one place in between, and write the sum of the digits in the middle. So this is the easiest way of doing multiplication by 11. Do the following operation. First, keep the digits 3 and 6 apart by one place and put the sum of the digits in the middle place. That is the easiest way to do multiplication with 11. In fact, this is what is going to be considered as the magic property of 11. So what is the digit sum of 396? It is going to be 9. The digit sum of 66 is nothing but 3, and the digit sum of 6 is going to be 6 itself. So 18 is the product of 3 and 6 that has a digit sum equal to 9, and hence the multiplication is verified. So let me leave the remaining practice problems for you to solve at home. Now comes the important lesson that we learned for today. So I'll just take away the screen share and try to show you the hand. Let me see if the hand is visible to you. Is the hand visible? If the hand is visible, you can just put that in the chat box. And okay. So what you have to do is you can hold your hand like this in front wherever you are sitting. Okay. Now we are going to see a rule for multiplication table of 9. Some of you might already have seen this. So what you have to do is keep the palm facing towards your face and count the numbers from your thumb. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the left hand thumb is going to be 1 and the right hand thumb is going to be 10. Okay. Now what you have to do is, suppose you have to do 3 multiplied with 9. What you have to do is just fold your third finger. 1, 2, 3. Fold your third finger. Now count the digits or count the fingers towards the left side of the folded finger, which is 2 in this case, and then count the numbers to the right side of the folded finger. That is going to be 7. So the answer to 3 times 9 is going to be 27. You got it just using your fingering. You just folded the third finger, and the number of fingers towards the left will give you the first digits. The number of fingers towards the right would give you the second digit. Let's try one more example, a little bit harder. 8 times 9. So which is the 8th finger here? So I'll just start counting. 1, 2, 3, 4, 5, 6, 7, 8. So fold the 8th finger. How many fingers are towards the left? It is 7. Towards the right, there are 2. So the answer is going to be 72. Now, this is for students who find the multiplication table a little bit confusing. We have a lot more fingering mathematics that is going to come up, which I'll introduce bit by bit so that it becomes easy for you to digest. So let us move ahead. So just to become a little more clear on this, I'll just show the numbering. So you hold your palm towards your face and you start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is how you can do multiplication by 9. Just fold the number that is intended to be multiplied with 9. So let us move ahead. So the next one is again a very useful technique while answering problems that have hard multiplications. So this is known as first by first and the last by last. This can also be easily be used as a sanity check rule in an approximate sense. We shall explain what it means. So we all have heard first things first. So in order to give an approximate answer, what you can do is round off the number to the nearest tens place and then do addition or multiplication. In this case, we'll do multiplication. An example is given here. If I want to find what is the approximate answer to 32 times 41, how will I do that? Drop the 2 off from 32 and 1 from 41. You will get 30 times 40, which is 1200. Approximate it to the nearest thousands. So you can say that this number is approximately 1000. If you don't want to neglect that 1200, you can directly say it is near to 1200 as well. Let us find the approximate answer to 641 times 82. Again, you can multiply 600 times 82. 600 times 80, in fact, by dropping 41 and 2 from these numbers respectively, and you will get the answer to be 48,000. So this number is going to be greater than 48,000 because we have reduced 41 and 2. But an approximate sense, if you want to go to a shop and just ask how much does 20 items of a particular choice, how much cost you have to pay. So the shopkeeper will most often say an approximate figure. So this is how you do that. Again, 39 times 63, you can do 40 times 60, which is 2400. Now I'm introducing the notation for approximation. So if you want to just say the approximate value of 383 times 88, you can use this slightly bent version of the equal to sign. This is denoting the approximate. So what is the answer to this? You can do 400 times 90. What is 400 times 90? That is 3 zeros. So this answer 383 times 88 is approximately 36,000. And in fact, the actual answer is going to be less than that. Now we'll go to the last part, last by the last. So this is a useful exercise for you to check answers once you have completed the procedure of solving. Essentially useful for word problems. So often we have heard we should not consider the last to be the least. We should even make use of the last elements. So this is how you can do that. 72 times 83. What is the last digit of 72 times 83? So this can be just found out by 2 times 3, which is 6. We are just interested in knowing the ending digit. So that is just 2 times 3. What about 383 times 887? 3 multiplied by 7 is 21, but you cannot give 21. You have to just give one digit. So 1 is the last digit. What about if you have to multiply 3 numbers? 3 times 8 times 3 you can do. You are just picking out the last digits of each of the numbers. So this is nothing but 9 times 8, which is 72. So 72 I'll skip 7 and write just the last digit, which is 2. Now you can just practice some of this. I'll just do the addition one. How to do the last digit of addition, that is also direct. You take the last digit in each of these places. 8 plus 5, which is going to be 13. So the last digit is going to be 3. So let me just pause here to check if my audio is right with everyone. I can see some raised hands as well. So I urge you to wait till the end, till the lecture is completed, for taking up questions. Hope you have digested some of the facts that we have introduced here. The main point was to learn about sanity checks, whether it is possible to give instant results to see if your answer is correct or not. And in between, we have introduced a little bit of finger mathematics just to exercise your fingers. You can use multiplication by 9 by just taking your fingers and folding the relevant digit and just counting the fingers towards the left and the right. You are essentially going to get the answer for multiplication by 11. Let us move forward. Now we come to this magic number of 11. We have seen this magic property, how we can avoid the traditional way of multiplication when it comes to 11. This course will also teach you another magic number. As we go ahead in some of the lectures, we shall introduce one more magic number, which I will keep for suspense. So the first magic number is 11. What is the property of 11? It is having repeated ones. So the repeated ones is just allowing you to add adjacent numbers. You might have noticed when we did a multiplication with 11, we did 11 times 36. And this 11 times 36 was just done by placing 3 and 6 apart and just replacing the middle number by the sum of the digits. So essentially what the 11 is doing is you can paste 11 like this. So in the units place, only 6 and 1 coincides. So when only 6 and 1 coincides, you are going to get 6. Now you just move 11 by one place where you're going to get 11 moved completely over 36. Then you're going to get 3 plus 6 because you're going to multiply each digit 3 into 1 and 6 into 1. That forms 9. And finally, you have to just shift 11 by one more place so that it coincides with 3. So you have 3, 9, 6. So hope that was a useful information. Now we'll go ahead. We have talked about these repetition properties of 11. We can try some more examples. What is 23 times 11? So the rule is same. You separate 2 and 3 by one place and put the number, which is the sum, in the middle, 253. What about 45 times 11? You place 4 and 5 at the end. In the middle, you put 9. What about this one? Here you require a little bit more out of the box thinking. You can put 6 and 7 at the end, but there is a small problem that is arising. 6 plus 7 is going to be 13. So if I insert 13 here, there are 2 digits. So the thing actually to do is 3 with a subscript of 1. And the actual answer is going to be 737. Let's do one more. 88 times 11. How do we do this? 8 and 8 at the end. What about the middle number? It's going to be 16. So here you have to put a little bit more care. 6 and 1 here. And this answer is going to be 968. If you want to avoid writing, you can put this in the mind. You can see that the number 8 plus 8 is going to be 16. and there is 1 going to be getting carried over to 8. So you can directly write the answer to be 968. So we'll go to some variations where we can utilize this fact of multiplication with 11. Let us see. So here we do not see 11 directly in the products, but we can always convert this into a product with 11. So this can be written as 11 times 2 times 27, which is 54. So we know how to do this. 5 and 4, you place them apart and put the sum in the middle. What about 88 times 3? This is 11 times 8 times 3 is 24. Again, you don't have any issue. 2, 4, and you put the middle number, which is going to be 6. Now, the last variation here, we have, in fact, it's not a variation. We see the 11 itself explicitly. So we can go ahead with the direct. So here I will not write the first digit because I have already found out the sum of the digits is 15. So there is going to be a carry. So the answer is going to be 759. So if you want to do it in a conventional manner, you write 6 and 9. 15, you can write 5 as the bigger number and 1 as a subscript. And that one subscript would add up with 6 to give 759. We have few more practice. Let us pick one here. Let's do the last one. So this is going to be 77 is going to be 7 times 11. So you can group 7 and 6 to give 42. So this is going to be 11 times 42. And we know the answer to this. This is 462. So you do not have to do any kind of regular mathematics multiplication where you write 77 times 6 like this. This is in fact going to take away a lot of time. So as we have just pointed out before, you have to develop an eye to find patterns. The whole idea of this course is itself allowing yourself to develop this this practice of observation of the patterns. This is very useful for worded problems as well. There is some pattern for the problems which you essentially, if you pick it up, you can easily go ahead and solve. Let us do one more example here, which is 22 times 31. This is nothing but 11 times 2 times 31, which is 62. So this is going to be 6, 8, and 2. Hope the ideas were clear up till now. Now let's see some large numbers where this magic number appears. What about 2, 3, 4 times 11? Now we are going to the domain of 3-digit numbers. So I'll just show with the method that we just introduced. What you can do is start from the right. You can as well start from the left, but just to obey the convention of right to left, we can start from the right, and the first number is going to be 4. The next number is going to be 4 plus 3, which is 7. The next number is going to be 3 plus 2, which is 5. And the last number is 2. In fact, you can see the magic how multiplication by 11, you have already eliminated all the intermediate steps. What you have essentially done is some digit sums, and these digit sums are done in pairs. Let's do this example, 417 into 11. You can start from the last digit, which is put as it is, 7. Then you do 7 plus 1, which is 8. Then you do 1 plus 4, which is 5. And then put the first digit, which is 4. What about the next one? 5, you begin with 5 at the rightmost place. Then you have 5 plus 3, which is 8. Again, you have a little bit of doubt when it comes to 8 plus 3, where you have 11. So 11, you have to write like this and put 8 here. So this is going to be 9185. So let me just explain once again what happened. So the last digit, which is the rightmost digit, is 5, which is put as it is. Then next digit is 8, which is 5 plus 3. Again, the third from the right, which is 3 plus 8, which is going to be 11, but I won't write 11 as it is because it is 2 places. So I'll just write 1 with a carry 1. That will carry over to the last place, which is 8. So the final answer is going to be 9185. You can do similar action from the left to right as well. So the Vedic mathematics promotes left to right operation. If you want to do left to right, what you can do is the same thing. Put 8 first, then 8 plus 3, which is 11, but you know it has 2 digits. So you'll write like this. Next number is 3 plus 5, which is 8, and the last digit is 5. Essentially, you're getting the same thing. Here are a few practice for you. Let us do the last one here. The remaining you can take home. What is 807 times 11? So again, the simple rules follow. Let us do the left to right operation here. So I write 8. The next number is going to be 8 plus 0, which is 8 again. The next number is going to be 0 plus 7, which is 7. And the last one is kept as it is, which is 7. Another way of seeing the same problem is number splitting. You can write 807. You can split the numbers. So 807 is split as 8 with a split of 07. Now you can multiply 11 with each of these splits. 8 times 11 is 88, and 8 times 07 is 77. So you get back the answer. We will elaborate on this procedure of splitting of numbers in the next lecture, where it is useful even while we do additions, subtractions, multiplications, or even divisions. Let us go ahead. Now we are left with another few minutes before we end. So I just want to introduce 2 puzzle problems which will appear in today's quiz after the lecture. So here the problem is just reading as follows. You have a 3-digit number 40, and the last digit is hidden or hidden. So you can see the last digit is hidden. Now the whole idea is you have to find what is the hidden digit. Suppose the condition 40 divided by 27 is equal to 1 followed by the same hidden digit. So I'll just explain it once again. So what you have to do is find the hidden digit of this particular number, this 40 dash. Now this is a hidden number. I think there is a small incompletion here. So this should have been the hidden digit that appears here. Okay, so essentially it says that 40 and the hidden digit is there. This divided by 27 will give 1 followed by the same hidden digit. So I'll just make this correction while I post it in the final entry in the quiz. So you have to generally use the idea of the place value and the value occurring at that particular instant of place. The second puzzle is very interesting. In fact, I'll try to give a solution for this. The second puzzle reads as follows. There is a person, Malu, who has added the first 10 positive integers. Well, what are the first 10 positive integers? It starts from 1, 2, 3, etc. up to 10. Now, she has forgotten to add one of the numbers. But the sum, she got it to be the sum of all the first 10 integers except one. She has got it to be square of some number. You know what is square of a number? So 2 squared means 2 into 2. So similarly, what she has got is a number x squared. This x is unknown. The sum is also unknown to some extent because she has missed one number and she does not remember what she has missed. Now the whole goal is to identify which number she has missed. A little bit confusing, isn't it? So let us try what we can do. In one of the previous lectures, we had introduced the sum of first n consecutive numbers, in fact, natural numbers. So sum of consecutive natural numbers was given as n times n plus 1 by 2. Some of you have already seen this. If you have not seen it, it is a useful result to learn. So what it says is that if I plug in n equal to 10, I'll get the sum of the first 10 positive numbers. So let me just plug n equal to 10, and that is going to be sum, but it is the sum of the first 10. What is that? 10 into 11 by 2. This is going to be 55. Now, let us see if you can help Malu to find the digit or the number that she has missed. So she is going to get a sum which is less than 55 because she has missed one of the numbers. So 55 minus some number, let me call that number as y, that is going to give the square of some integer. The square of a number, which is this x is going to be an integer. So what is the largest value of y that she can take off? Anyone with a guess? The largest value in between 1 and 10, that is going to be 10. So this 55 minus y is definitely 45 or greater than 45. Now, what is the number whose square is between 45 and 55? Yes, the answer is going to be 7. The square of 7 is 49. So the only square of an integer which is going to lie between 45 and 55 is going to be 7 squared. So this x is going to be 7. So 55 minus y is going to be 49. This implies y is nothing but 6. So the digit or the number that she has failed to add with all the consecutive digits is going to be 6. So here we have a little bit of formulae to learn, which is just this n into n plus 1 by 2. So if you know this simple formulae, a question that seems to be impossible to understand or solve seemed plausible just because of the fact that we had assumed this x to be an integer. So this is the little bit of tips that you can get from word problems. I encourage you to try even more word problems from wherever source or whichever source you have access to. So I think with this, I'll just end today's discussion and open the floor for questions. So participants can just unmute themselves and ask the question.
Okay, sir.
Anyone with the questions? So let me just check the chat box also in the meantime. Yeah.
Sir?
Yeah, please go ahead, Hemant.
Sir, please explain finger mathematics, sir, finger multiplication.
Okay.
Sir, finger multiplication.
Yeah, sure. So let me just do the finger multiplication once again. So everyone can hold your hand like this in front wherever you're sitting. So you keep the palm facing towards your face. So
Sir.
suppose you want to do, say, 2 times 9. If you want to do 2 times 9, you just fold the second finger which is the index finger of your left hand. Index finger is the finger next to the thumb that you fold and open all the remaining fingers. Now count the number of fingers towards the left of the folded finger. What is it? What is it? That is going
9.
to 1. And the number of fingers towards the right is going to be 8. So the answer of 2 times 9 is 18.
18.
So this is only to be used if you have some difficulty in
Sir,
learning of the
this can
multiplication.
only be happen with 9 only.
So today I have only considered 9, but there are some special cases as well, which I will take in some other lecture. There are some more finger mathematics that are available. I'll just teach one by one in each lecture.
Okay, sir.
Okay.
Sir, want to say multiplication table of 9?
Yeah, multiplication table of what? So currently
9.
the finger mathematics only works for 9, whatever we had taught today. If you want 8, you will have to do different technique, which I'll teach you in the next class.
Okay, sir.
Yeah. Are there some other? Yeah. Yeah, please go ahead.
Sir? Sir,
Yeah, please.
finger multiplication is only for 8 or only for 9 or only 8?
Yeah, that is what I was explaining. It is on currently whatever I have taught is for 9. I'll take the multiplication for other numbers as well in the next class. So just wait till the next class.
Okay, sir.
Okay, sir.
Okay, sir.
Okay, sir.
So hope you have enjoyed
Okay, sir.
today's
Thank you.
lecture. So those who have come for this lecture, maybe in the last class or even today, you can find the previous lectures available on YouTube. So just go to Practically YouTube channel and see the lectures.
Okay,
So
sir.
I'll end for today. So see you next week. Thank you and namaste.
Bye, sir.
Bye, sir.
Thank you, sir. Bye, sir.
Bye.
Bye, sir. Bye, sir. Bye, sir. Bye, sir.
Bye, sir.
Bye, sir.
Bye, sir.
Bye, sir.
Bye, sir.
Bye, sir.